Here we go. What's up, everyone? Vin here, and welcome to the second day of the May 2025 AP Calculus AB and BC live stream review. So people just let me know in the chat if the audio is coming in nice here, and I will start at 7:45. But for the first 2-3 minutes, I'm just saying what's up. So seeing some people say that they're scared. That's normal. Night before the test, morning of the test, you're definitely going to be a bit anxious, but you just show up and you do your best. You're doing what you can right now by reviewing, but I'm just going to go through some free response questions and then we will see. So yeah, at everybody here, hello. I see we got 32 people already on, and yeah, we're just going to get rolling here, but let me see. Yeah, some people, their test is in a few hours, so I guess I will just get to it. Okay, so let's just see. Oh, studying units 9 and 10. BC free response question is going to be lit this year. Yeah, I mean, we don't know what kind of FRQs we're walking into, but I will. Guys, we're getting fives. Yes, at Emma, I'm also on everybody's side here. What's it called? I hope you all do very, very well. And yeah, wishing everybody the best. So, all right, I guess we will get rolling here. And if anything pops up in the chat, like I'll address it, as I see it. But we do have 9 FRQs to cover. I'm going to do a full set of questions from 2003, going pretty far back, but they're still good questions. And then for BC, I kind of mix and matched a little. All right, so this one here was from... Let's see. This is what year is 2003. Okay, so yeah, you all weren't even born yet taking AP Calculus. But for this one, part A, we have a graph of f of x and a tangent line. And for part A, they just want us to show that L is tangent to the graph of y equals f of x at x equals 3. Okay, so this is occurring over here at x equals 3. So for one, what I would do is, and the line, just so we're clear, is given here. The equation is, they're saying this is the line y equals 18 minus 3x. So if we're going to show that this is the tangent line, what we should do first is plug 3 into the function. Okay, and this is, I should point out, this was a calculator friendly question. So we are allowed to use a calculator here. So f of 3, I could use a calculator, or I could just plug in, and we get 4 times 3 squared. So we get 9 times 4 is 36. And we're doing 36 minus 27, which is equal to 9. Okay, so the point is going to be 3 comma 9. And what's nice about this question is we know what tangent line we should be getting. So if we don't get that, we could always just retry it and maybe better luck next time. But to write the equation of a tangent line, you need a point and you need a slope. So this represents our point x1, y1. And the slope is going to come from the derivative f prime. So here I just do the power rule. I have 8x minus 3x squared. And I want to know what is the slope of f of x at x equals 3. Okay, the instantaneous rate of change at 3. So I get 8 times 3 minus 3 times 3 squared. And that gives us 24 minus 27 is negative 3, which matches the slope we have here. Okay, so then what we have next, the tangent line. So the, well, I'll just write it out. So I'll just write the equation out. So we have y minus 9 equals negative 3 times x minus 3. And now I'll solve this for y equals. So we distribute, and we've got y minus 9 equals negative 3x plus 9 when I distribute, and then plus 9 on both sides gives us y equals, and I'll write 9 plus 9 is 18, and then minus 3x. Okay, so show that that L is tangent to the graph of y equals f of x at the point here. So I'm just going to say, therefore L is tangent to y equals f of x at the point x equals 3. Okay, so I'm just writing it in the language of the question. So, nice part here to warm up. This is worth 2 points. If you just find f prime of 3 and f of 3, you get 1 point. Okay, which is something I want to point out with the FRQs, is that in the free response, sometimes like students will think like, I don't know how to do this, it's not worth it. I'm going to do a Taylor last at Alex Griffin. So there will be a Taylor at the end. So, yeah, that's going to show up at the end. You could go in the description. I linked the questions I will be going over. So if you want to see ahead of time what I'm going to be talking about, by all means, download that PDF. Okay, so next is find the area of S. So we want this. Well, one of the things we just showed here in the previous part was, for one, like this is the 0.39. Okay, so now I'm going to drop this down. I want the area of S, but what I'm going to do is I'm going to drop this down, and I'm going to make a right triangle, because this is a straight line over here. So in purple, we have a right triangle. So the area of S, I'm going to say, is the area of the purple triangle minus this pink area over here. And do you all see how f of x, so y equals f of x, I'm going to highlight in red, is here. Okay, so here is f of x. So for part B, what I could do is I could find the area of the purple triangle. So that's 1/2. And if we're like, oh no, where does this end? If I set y equal to 0, so 18 minus 3x, when is that equal to 0? When x is equal to 6. So this occurs at 6, 0. And that'll help us find the area of the purple triangle here. So I could say 1/2, the base is 3 units long, and the height is 9 units long. So I'm doing 1/2 base times height, but now minus the area of the pink. So now the next phase here, I could use a calculator for this, but the algebra is not that bad. When is f of x equal to 0? Well, f of x is equal to 0 when, I'll write the factored form here. I'm going to factor out, see how it's 4x squared minus 3x? 4x squared minus x to the third. If I factor out an x squared, I have 4 minus x left on the inside, so I have 2 roots. X equals 0, and we have even multiplicity, that's why it's tangent over here at 0, and x equals 4. Okay, so x equals 4, that's this location over here. All right, now how that helps us is the area of the pink, this region over here, is the integral from 3 to 4 of f of x dx. Okay, and this is the calculator section, so I'm not going to anti-derive that myself, okay, or, anti-differentiate. We got into the, the terminology yesterday, but yeah, technically, like, derive and anti-derive is a little, I guess, slang. It's probably cleaner to say anti-differentiate, but time is money, right? Okay, so here, calculator, let me open this up. Let me make sure it looks good in the window here before I just start typing away. So let me adjust this a bit. Yeah, I think we could still see that. Okay, so 0.5 times 3 times 9, and then minus math 9 pulls up the integral 3 to 4. And now f of x, what I want to do is I want to write f of x over here, because realistically for a lot of questions I like to have it saved over here, the function. Okay, and I'm going to show you like some shortcuts you could use. So on the main screen, if I were to write an f of x over here, I could retype it. I could write 4x squared minus x to the third, or I could press alpha trace y1. Someone last year told me how to do it in 2 buttons, but I forgot. But this is still pretty good. And you get 7.9167. I'm sorry, 7.917 if we round. On the AP test, though, you could just chop. You could just say 7.916, but if we round to the nearest thousandth, it's 917. Okay, so this is 7.917. All right. I just would rather round it properly than like not round it properly, because I feel like it's sloppy math if I'm like, yeah, who cares about rounding? Okay, cool. Second vars, if that's the shortcut. Let me see. Second vars. Wait. Second vars is normal. All right, maybe I'm missing something. Whatever. But cool. Second vars. Why not? All right. Back to this stuff here. So now the last part, find the volume of the solid when R is... So find the volume of the solid generated when R is revolved about the x-axis. So one thing to point out here, R is the region bounded by the graph of F and the x-axis. Okay, so if I erase some of this stuff here, see how R is this space. So I'm going to do this in orange. Okay, so here's R. Okay. And now if I'm revolving this around the x-axis, the two main cross-sections you have to know for volume of revolution are, you need to know the disk and the washer. Revolving around the x-axis, and region R is like right against the x-axis. We're going to go with the disk. Okay, so our cross-section is going to look like this. It's going to be solid. And the radius is going to be equal to f of x. And this is going to be dx. And the volume of one slice, so dv represents like a tiny slice of volume, is going to be pi times the radius squared, but then dx. But that only gives us the volume of one slice. And we got to see that region R, see how it goes from 0 to 4. So we're going to integrate now from 0 to 4. Okay, so 0 to 4, and now the volume equals, and I just typed this in the calculator because it is the calculator section. Okay, so I pull the calculator back up, and now I could say math 9, 0 to 4. Make sure you're in radians, even though we're not using trig here, but still. Second up, and now f of x is alpha trace y1, and that piece is being squared, and then dx. Okay, so this types in pretty nicely here. 490.208. Okay, so 490. Whoops, 490.208. All right, I really like to draw the cross sections out because then this is just like basic geometry. It's like you're finding the volume of a cylinder, but you know, like the calculus version. All right, cool. All right, moving on. Oh, wow, we got 140 people here. And I will say it after every FRQ, but if you have not subscribed, and this is helping, please consider subscribing. Help me grow this channel. And yes, manifest those 5s at Sparks. I hope everybody here gets a 5. Now, look, realistically, like, you know, I hope everyone in the world taking the test gets a 5. But if you don't, like, it's okay. You're going to get something out of this test no matter how you do. Proud that you're just even entering the arena. You're brave enough to sign up for a class like AP Calculus. Oh, it's Sophia. Hello. Hello to all. Special shout out to my period 1-2 people. So I see we got Ben, Sophia, and everyone else. You know, hello. Nice to see you all. Well, in the YouTube world. Okay. So now, all right, this one I broke up into 2 pages, but it's like 4 parts. This is the classic rate in, rate out question. Okay, so this is rate in, rate out. You could like basically guarantee that rate in, rate out will be on the AP test. This shows up just about every year. I would be shocked if this is the year that they're like, nah, we're done with it. But yeah, this one is a good question to know. So one of the big ideas is that the integral of the rate tells you how much. Okay. Oh, what percent is a 3? Yeah, like kind of like around half-ish, maybe a little less. So in that range. I'd have to look at an actual test. Someone could pull up one of the IPEs. Yes, at Aiden, this is the last stretch. This is as final as it gets. Okay. Like we're as down to the wire as it gets. But you're going to be great. I'm proud once again of everyone here and my students that I work with the whole year. I'm proud of the group. You're all fantastic. Okay. I think tomorrow is just another day in school. All right. You got this. And I love the chat too, that you're all so supportive of each other. Like Thank you for being great. So here, the part A, how many gallons, or maybe we should read it. A tank contains 125 gallons of heating oil at time t equals 0. This, I'm going to say right here, is like a potential trap. Okay, I'm going to say potential. My phrase is always the bear trap. All right, I need to have a bear on here that just roars when I need it. But if you forget this, it could mess you up later in the question. Okay, so just don't forget that. We don't need it necessarily right away, but we will need it at some point. During the time interval 0 to 12 hours, the heating oil is pumped into the tank at a rate. So this H of T, if it's being pumped into the tank, this is the rate in. And now heating oil is being removed at a rate. This is the rate out. Okay, so when we say rate in, rate out, like this is what we mean. But now the question is, how many gallons of heating oil are pumped into the tank? Okay, so the pumped into the tank is dealing with the function h, and is during 0 to 12. Now with this one, where students get confused, it's like, they're like, oh no, do I like integrate h? Do I plug into h? Or do I like derive and plug in? And they're like, oh no, which one is it? Like question mark. I don't know what to do. The key is understanding the concept. All right, the reason why we're integrating here, so we're going to do the integral of h of t dt from 0 to 12. And the reason we're doing this, I pay attention to the units. We have heating oil is pumped into the tank at a rate of h of t equals this, gallons per hour. Okay, so this is gallons per hour, and dt, time, is measured in small increments of hours. So hours over hours would cancel when you multiply these, telling you how many gallons. When they say how many gallons, that's why you're integrating the rate. Okay, the integral of the rate tells you how much. And now this we just math 9, but the hard part is knowing what to tell the calculator. Okay, so what for this question I would want to do ahead of time is, sort of like what I said before, is I want to type the rate in and rate out into the calculator right away. Okay, and I really, at this type of question, I'm really just trying to say to myself, please don't make a typo. So I'm doing 2 plus, I press alpha y equals enter to pull up a fraction, and then I have 10 over, and then we have 1 plus natural log of t plus 1, but I'm going to write x plus 1. Okay, so that's our rate in. And now for the rate out, we have 12 times sine. I'm going to go alpha y equals enter again, just to really play it safe. X squared over 47. Okay, and we are in radians here. So now rate in is y1, rate out is y2. So now I go back to the main screen, and for part A, we have to do math 9, the integral from 0 to 12 of the rate in, which was alpha trace y1 every time, because that's going to take up too much energy. Okay, so we're going to get 70.571. Okay, 70.571 for this first part. Okay, so we'll just write that in, 70.571, or you could just chop. All right, so this is our solution to A, and it's worth 2 points. So now, for the next part, part B, we want to know, is the level of heating oil in the tank rising or falling at time t equals 6? So with this one, for part B, it's like a battle between the rate in versus the rate out. Okay, I always think of it in terms of, like, let's say a sink. Like if you had a sink and water is like, pouring into the sink. Okay, so you have some sink and water is pouring in. Okay, so just imagine like the water's coming out and it's like filling this up. If the water is really coming out fast, and let's say there's like a little bit of a clog in the center, you see how like the rate in is greater than the rate out. It's pouring in faster than it's draining, so the water level starts to rise. So that's kind of what I see here, that I'm going to compare the rate in, H, and the rate out, R, at t equals 6. And if oil is coming in faster than it's exiting, then the level of heating oil is rising. If it's draining or leaving faster than it's coming in, then the heating oil level, I'm sorry, the level of heating oil will fall at that time. Okay, so that's the concept behind what's happening. So really all I have to look at here, I could compare them on the main screen. So you know what, I'll do that. I'm sorry, I compare them on the calculator over here. So let me go ahead and do that. So, and this is all happening at t equals 6. So I could press alpha trace y1 at 6 and compare that to alpha trace y2, the rate out at 6. And see how we have these two. If I wanted, I could also just subtract these. Like some people like to show like rate in minus rate out is negative, and that means the level is falling. But you know, there's more than one way you could do this correctly here. Okay, so I'm just going to drag these to here so we could use this to write our argument. Okay, so for part B, you know what, I'll just say it the subtraction way. I'm going to say that, you know, h of 6 minus r of 6 is negative 2.924, which is less than 0. Okay, so this is, once again, the rate in and the rate out. Okay, so that means the oil is leaving faster than it's coming in, so the level of oil is falling. All right, so here I would say, therefore, the level of heating oil is falling at t equals 6 hours. Okay, so I'm just using the evidence to write the sentence. And when they say give a reason, like this is the evidence to write your conclusion here. If you just say, oh, it's falling because I'm just guessing, they're not going to give you anything. Okay, this was 1 point. Answer with reason. All right, so now we're at a 3 out of 9. So for the last 2 parts here, I have this on separate paper or on a separate page just for space. We've got same scenario. How many gallons of heating oil are in the tank at time t equals 12 hours? So for this one, remember when I said before, like, don't forget this? Like that would be now. So for this, if I break it down in stages, we have 125 gallons already there. Plus from 0 to 12, we could do the rate in, but now we have to account for how much oil leaves or how much oil is removed. So minus R of t, dt like this. Okay, so we have to do the rate in minus the rate out. And for that, once again, just back to the calculator, and I'm just going to type this in. We've got 125 plus math 9, 0 to 12, alpha trace y1 minus alpha trace y2. And then dx, enter, and we get 122.026. Okay, so 122.026. So 122.026 is our solution to C, and that's worth 3 points. So, you know, for these rate in, rate out questions, I think they're all like pretty fair. They're not too terrible. The only part I would say that's kind of tricky is like this one. At what time t is the volume of heating oil in the tank the least? Okay, so we're finding a minimum value here. Okay, and I should say we're finding like the absolute minimum value. So this is where unit 5 comes in, and this one is like usually the hardest part. But if you develop a feel for these, they're not the worst. So for this, what I'm going to do is I'm going to write a function. I'm going to call it a of t, and I'm going to say that this is the amount, or I'll say, you know what, volume of heating oil, like volume of heating oil in the tank, okay, at any time t. So in the tank, and this is going to be equal to 125 plus, but now I'm going to say integral 0 to t like this. But if I do this, it's sloppy. If I say h of t minus r of t, I should re-index this and say h of x minus r of x and then dx. Okay, so if I want to see when is the volume of heating oil in the tank the least, then I'm going to use the closed interval method here. And we're on the interval here from 0 to 12. So I'm going to take the derivative, a prime, And this, we have to know this formula, the derivative of the area function. We have a constant a. So this I'm just going to treat here as a constant. To, let's say, x of f of t dt is just equal to f of x. Okay, so that's the formula I'm using here. So I have the derivative of 125 is 0, but then I have plus. And if I'm deriving with respect to t, this becomes h of t minus r of t. So I really want to know, when is this equal to 0? Okay, so a prime equals this equals 0 when, and now back to the calculator. So I have to look for h minus r. So let me pull this up. And let me check in on the chat here. How's everybody doing? Could you keep h minus r inside? Yeah, okay. If you keep h of t minus... Oh no, the mic is cutting out. So yeah, other people let me know if the mic is cutting. Oh no, that's pretty sad. Let me see. Oh, all right. I don't know why it's lagging. That's a little bit annoying. Let me see if there's a way to... Oh, it's not for you. Mic's good. All right. Maybe it's like just this parts of the country. All right. Hopefully we're good now. So, oh yeah, the calculator. I was like forgetting where I was. I'm like, oh yeah, you're live streaming and you should teach people how to do this. So we have y1 minus y2. See, this is h and this is r. So I'm going to do alpha trace y1 minus alpha trace y2. And a little trick, if you don't know this one, you go to the equal sign and you press enter, and that will turn the graphs off, but not erase them. Okay, so it's only going to graph h minus r. And if I want to know when the graph is equal to 0, then I'm going to go to the window, and the interval here was from 0 to 12. See, from 0 to 12. So I'm going to go x min is 0, x max is 12, and negative 10 to positive 10. I press graph, and I've got two roots. Okay, I'm going to press second trace 5 to trace, I'm sorry, yeah, second trace 5 to trace the intersection of the 0 line and the graph. So you see how we get one of the points here at 4.7900515. I'm going to go to the main screen here, press second mode, second answer, and I'm going to store this as the letter A. All right, so I'm going to use that value in a moment. And then I go second trace 5, and I find the other one. Okay, so I got this one. Enter, enter, enter. And there's the second time. Now, you could see like the derivative here is changing positive to negative and then negative to positive. So if you're looking for when things are at the least, then you really just need this one. But I'm going to check them all just for the exercise of it. Okay, because this is technically a local maximum at this time, and this would make a local minimum. So you can't have an absolute minimum at a local maximum. That just doesn't make sense. Okay, so here, second mode, second answer, enter, and I'm going to store that as the letter B. Whoops, wrong button. Okay, let's try that again. Store that as B. And now I'm just going to leave this on the main screen just because I'll never remember those numbers. Okay, so we got this. And for this, I would actually write down like the full time. Like it is the AP test. So I'm going to say when T1 equals 4.79. Well, hang on, my mouse is going a little crazy. 51464. And T2 equals 11.318,47025. And then what we're going to do is make a table with, let's see, we've got T. I'm going to call this A of T. And we've got 0, T1, T2, and 12. So I'm going to fill out this table. Remember, our function here, A of T, let me erase this now that we've got this. So A of T is this over here. So when I go back to the calculator in a moment, I'm just going to plug into this, okay, and get what we need. So let's go ahead and do that now. So we're going to have over here, so I've got 125 plus math 9. And now if I go 0 to 0, that's just going to give 125. So I'll start first at A was that first time. Okay, and if we look, see how in the y3 I have y1 minus y2? So I could just get that value by going alpha trace y3. Okay, I don't actually have to write rate in minus rate out. I'll just use that shortcut. And then this is the value that I get here. And then I just go back up to this. And for the next time, I want to go at time B, which was this. So I got this one. And then one more. At time t equals 12 is the end of the interval. So let me just go here and make this a 12. And we have all the values we need. Okay, so let me just drag this down. Because here, see how they say show the analysis that leads to your conclusion? So that's what I'm doing. Now, I said before, if I plug in 0, integral from 0 to 0 just wipes this out. So I just get 125. And then at T1, we got 149. I'll say 408, and then 120.738, and then 122.026. So at what time t is the volume of heating oil in the tank the least? Is going to be at T2. And the analysis, like we used, the closed interval method here for finding absolute extrema. Okay, so the volume of heating oil in the tank. Well, I'll just say the volume of heating oil. Let me just think how to phrase this nicely. Sorry, I'm like blanking out here. All right, the absolute. How about the absolute minimum? Minimum amounts. Yeah, maybe because I want this to sound nice too. I mean, as long as you get the idea across, but still, I feel like it's sloppy if I write a terrible sentence. So the absolute minimum amounts of heating oil occurs at time. Let me see. I'll say at T2 equals 11.318 47025. Okay, so see how this is the smallest value in the table here. So excellent. All right, that's the end of question 2. This one, once again is like sort of a lot, that process, but I don't know. I've seen a lot of these rate in, rate out FRQs, and like that's the kind of stuff you got to be able to do to be successful. So how are we doing in the chat? Let's see. Yeah, I mean, Desmos, if you're good at Desmos, like absolutely use it. But that would be if like you've been practicing it all year, whichever one you're more comfortable with. So that's how. Oh, how do I know to add t at the top of the integral and not 12? Because here I'm testing out times other than 12. If I put 12 up here, that just answers part C. That tells us how many gallons of oil are in the tank at time t equals 12. Okay, so that's what we were answering over here. Oh, I totally forgot that we already answered that in part C, but whatever. I guess I'm starting to get a little tired here. All right, but I gotta stay strong because we got a lot more questions to go. All right, so a nice table of values, Riemann sum type question. So write an integral expression in terms of b of x that represents the average radius in millimeters of the blood vessel between 0 and 360. I should point out a blood vessel is 360 millimeters long with circular cross sections of varying diameter. The table above gives the measurement of the diameter of the blood vessel at selected points along the length of the blood vessel, where x represents the distance from one end of the blood vessel. And here we go. B of x is twice differentiable. and that represents the diameter at that point. So this is where we got to be careful. They said here, this probably destroyed everybody in 2003. Diameter, and we want average radius. Okay, so when we set this up, people were probably okay with like, all right, formula 1 over b minus a integral a to b f of x dx. Like you might hear like average value of f of x on AB, and you might just be able to recite this formula. Okay, but the only trap here to be on the lookout for was that we're going 1 over 360 minus 0, integral 0 to 360. However, if we want the average radius, we got to take b of x and divide it by 2. Okay, because this is, once again, b of x is the diameter, and the radius of a circle is half the diameter. Okay, so this was very, once again, don't write this on the AP test, but this was very sneaky. Okay, they probably got a lot of people like that. All right, now, part B, approximate the value of your answer from part A using the data from the table and a midpoint Riemann sum with 3 subintervals of equal length. One thing I'll do though, before I do that, I'll clean this up a bit. This is 1 over 360, integral 0, and make that neater, 0 to 360, b of x over 2. Okay, because this is what we're going to simplify or approximate in the next part. So b, I'm going to say that this integral 0 to 360 b of x over 2 dx is roughly, and we've got 1 over 360, but now for this, if we're doing a Riemann sum and we're doing a midpoint Riemann sum, if you forget, okay, so this is like backup method. If you forget what's happening, the backup is to draw it out. Okay, so this is, once again, backup. If you could do this in your head without, like, or just using the table, then great. But if you're like, oh no, what's the formula? Then pay attention to this. So 0, 60, 120, 180, 240, 300, 360. And then I'm going to plot some of these points. So I'm going to say like, 24, then 30, let's say is up here, then 28, then back to 30, then to 26, then to 24, and then back to 26. Okay, and not necessarily drawn like how it's going to look, but like let's say, let's try that again. Something like this. So here, and then it comes down like this. So if I'm doing a midpoint Riemann sum, 3 subintervals of equal length, that was going to break this up like this. So here's like 1, 2, and 3. So on the first one, maybe I'll change colors. From 0 to 120, it's like I could go left, right, or middle. So I go to the middle here, and I make a rectangle like this. Okay, so this rectangle is going to be 120 wide and going up 30. The next one I'll do in, let's say I'll go blue here. I'm from 120 to 240, but 180 is in the middle. So I go here. Okay, so the next one's going to go to this. And then for the last one, I'll go in pink. I go 240 to 360, but 300's in the middle. So like this is how the values are being selected. Okay, that's how we're getting the values. Just in case the concept, like you're kind of stuck here. All right, so now let's do that. But this is, once again, for b of x. We are still doing b of x divided by 2. All right, so for 1, each rectangle is 120 units wide. Okay, so you see that? So I'm basically multiplying them all by 120. Okay, so I'm going to leave space now. And for this, I have b of 60. See how the value here at 60 is equal to 30? So I'm going to have 30. But I'm doing b of x divided by 2. And then plus the next one, see how for the next one here at 180, or at 30, so I have plus another 30 divided by 2. And then plus, for the last one, we use the function value at 300, which was 24. Okay, but it's b of x over 2. All right, but all of them, these rectangles have a base of 120. That's why I'm multiplying them all by 120. And now for the rest, I could just simplify this. All right, so let me move this out of the way and simplify. I'll pretend this is no calculator, but this question here, let me bring the 0 back. So this question, like you could either leave it unsimplified, or if you have a calculator, you just type it in. All right, so here, I notice 120 over 360. So if I'm doing this no calculator just to simplify. Otherwise, once again, just leave it here and leave it unsimplified. Like you could leave it unsimplified. But if you want to see it through, then this would make 1/3 of 15 plus 15 plus 12. Okay, and this is going to give us 1/3 of 42, which is 14. Okay, so we're going to get 14 here. Will tomorrow be polar? Maybe. Yeah, I don't know. It's tough to say. Wow, 1,000 views already. Thank you all so much. We are in the first 40 minutes, and we already had so many people showing up. If you haven't subscribed, please consider subscribing. Help me grow this channel if this is helping. All right. So next. So using correct units, explain the meaning of this in terms of the blood vessel. Okay, well, for one, see how they said in the beginning that B of X is the diameter and the blood vessel is 360 millimeters long. So if you look here, if you do, this is basically the, but now think of, when have you seen, like this to think about now, pi times the radius squared times dx. So this is the area of a circle. And they said the cross sections of this blood vessel. So like, I don't know, it's like some like blood vessel that could be like expanding and coming back, like whatever. And each cross section is a circle like this. Okay, so at any point, like maybe, ooh, like this part is like enlarged like this, but all the cross sections of this blood vessel are circles. So pi r squared dx is giving you the volume. Okay, so the volume of the blood vessel. This is sort of like the disk method in a way. So for part C, and another thing to point out, this is from 125 to 275. So this, like that's how I'm like piecing this all together. What is the meaning of this integral in terms of the blood vessel? Is that let's see, using correct units. So the volume would be in cubic millimeters too, because if we're measuring the diameter in millimeters and the distance in millimeters, then we're talking like cubic millimeters here. So this part here gives us the area, but the entire thing is the volume in cubic millimeters. So now we just write this all out. Okay, we could say, once again, that pi times B of X over 2 squared dx is the volume of a disk. Okay, so I'm just pointing out like that I recognize it. So, and I'll say therefore, the integral pi times the integral from 125 to 375, 125 to 275 of B of X over 2 squared dx is the volume of the blood vessel, and using correct units. So the volume of the blood vessel in cubic millimeters from X equals 125 millimeters to X equals 275 millimeters. Okay, and I'll say, yeah, so this, so from this to this. So it's a volume of the section of it. Okay, cool. All right, part D was like somewhat diabolical, like in terms of mean value theorem. So they told us that B of X was twice differentiable. Remember they said that here? B is twice differentiable. And they want us to explain why there must be at least one X where b double x is equal to 0. So we're going from b to b double. And it might be like, whoa, how's that going to happen? So for this, we could use MVT, or if you want to be really cool, you could use Rolle's theorem. But I guess we could just go ahead and use mean value theorem. So for this one, what I'm looking for is either 2 points that give me the same slope. So like, let's say the slope from here to here. See like the slope between these two and the slope between these two. See how it's a rise of -2 and a run of 60. Rise -2, run 60. So the same slope shows up twice, which would be more challenging, but it would allow us to use Rolle's theorem. But I'm going to use MVT because I think MVT is probably easier for most people. So the points that jump out are these two, because you see how they have matching y values, and then these two. Okay, but now in order to use mean value theorem, what we're going to have to do is mention that b of x is twice differentiable. Okay, means that b prime and b double prime. Okay, so let's think about this. If it's twice differentiable, that means that b prime is, you know what, I'll say this. I'm trying to think about how to say it as clean as possible. So yeah, since b is twice differentiable, I could say b prime is differentiable and continuous. Okay. And I'll say like b of x is differentiable and continuous. What this is basically doing here is allowing us to use mean value theorem to b and b prime in a moment. Okay, so that's just like getting the givens out of the way. But now, if we look, so I could say by MVT, there exists a value C1, and C1 is going to be between 60 and 180, okay, such that b prime at C1 equals b of 180 minus b of 60 over 180 minus 60. But notice that gives us 30 minus 30, which is 0. Okay, but there is going to be a C1 between 60 and 180 where this happens. Okay, so that's like a really big thing for this question. And now for pink, I could say by MVT, there exists another constant. This constant is between 240 and 360. Okay, such that b prime at C2 is equal to b of 360 minus b of 240 over 360 minus 240. But this also gives us, see how we're subtracting matching values? Gives us 0 again. So the fact that these match now tells us we could use mean value theorem again, but this time on b prime. Okay. So now I'm going to say by mean value theorem, so one last one, there exists a third value. Okay, let me write this a little neater. There exists a third constant, C3, and you see how we went from 60 to 180 and then from 240 to 360? So this value here, we could say is somewhere between 60 and 360. Okay, such that, and what we have for this part is we're going to have b prime. So now I'm going to say, because we're running out of space, I'm sorry. Such that now, once again, for this, the idea, I'm applying MVT to b prime now. Over here, I was applying MVT to just the function b. Okay, so instead of saying b prime at C2, now it's going to be b double prime at C. Okay, so B double prime at C3 equals B prime of 360. Or you know what? Let me backtrack a bit because I want to say this a little bit cleaner. But basically here, just so we could grab this, there is some value, B prime, C1 equals 0, B prime C2 equals 0. So let me just clean this up a bit. So B double prime C3, I could say at some point, is equal to the average rate of change. So we have B prime C2 minus B prime C1 over C2 minus C1, which is going to give us 0, okay? Which is exactly what we wanted to show. We wanted to show that this stuff exists, okay? So yeah, this one was a little bit funky, but basically like B prime is equal to 0 somewhere between 60 and 180, and then B prime is equal to 0 again somewhere between 240 and 360. So yeah, on that interval from C1 to C2, like this is where this is going to happen. Actually, I should clean this up a bit. I could just say like, honestly, like, and I'm sorry for making these adjustments, but I could say like this is going to occur between like C1 and C2, because wherever those points are, like C1 and C2, this is happening between there. Okay, so I'm targeting this like directly between C1 and C2, which is coming from the line before. All right, so yeah, that one was like pretty nasty. Like that was maybe one of the worst MVT questions I've seen, like ever. The only one that might be worse, if you want to see a bad one, or the IVT. So the worst IVT, I want to say it might have been, check out, oh wait, it might have been like AP Calc AB. Right now I gotta think. I think 2016. Look at the IVT question for that. If you have one more in you, that one was like a little bit nastier, I think, or about on par to be the same. Okay, so this one. So now, let me take a quick sip. Oh, bad audio lag. Is it more, what's it called? Like, is it chopping at Anch? Is it chopping, or is the lips, like my mouth, like out of sync? Sorry if the audio is not coming in clean. Oh, no audio lag. Chopping. Okay. All right. I mean, it might be, eventually down the line, I got to upgrade my computer. I haven't upgraded it yet. Okay. Do I think these FRQs are like some of the hardest? I mean, some of them are bad. Like not all of them. Like this one coming up, I don't think is the worst. I think this one's like lighter. Like some of them when I know I have to write, I'm like, oh, here we go. But like I didn't want to like cherry pick like old Disneyland questions that were too easy. So yeah. Oh, it could be your iPhone. Yeah, I mean, I'm gonna upgrade my computer eventually, and hopefully that cleans up some of the issues, because they're saying the stream's current bitrate and the recommended. They're saying they recommend I stream higher, but I don't want to like tinker around with the settings and then we just lose the whole feed. So hang in there. I'm sorry about that. Okay. So now next question. So we have V of t, find the acceleration at t equals 3. And this one I'm going to say is no calculator. I believe this one was no calculator. Okay, so acceleration, we are going to take the derivative with respect to time of our velocity function. Okay, and the derivative of -1 is 0. So I get 0 plus e to the 1 minus t, but then the derivative of 1 minus t is -1. Okay, so the acceleration function is negative e to the 1 minus t. So what is the acceleration at 3? At 3, we would have negative e to the 1 minus 3, or negative e to the -2. All right, so that's part A. Part B is the speed of the particle increasing at time t equals 3. So speed increases when velocity and acceleration have the same sign. Okay, so that's what we're looking for. So this was part A. For part B, we just do the at t equals 3, v of 3 equals -1 plus e to the 1 minus 3, which gives us -1 plus e to the -2. And for this, I know this one is less than 0 because the concept is that e to any power is always greater than 0. Okay, so for the, oh wait, actually, I'm sorry, I spoke too soon. Let me think about this. So what's the, oh, I see what we could do. All right, forget I spoke too soon. This was -1 plus. So if I have a negative plus a positive, then all bets are off. But although I could still say less than 0 here, let's see why. Oh yeah, because 1 over e squared, e to the -2 is 1 over e squared. So, and e is roughly 2.718. So this is a fraction less than 1. So if I have -1 plus something less than 1, it's still going to be negative. Okay, so that's how I know this one is negative. And then a of 3 from before was -e to the -2, which is -1 over e squared, and this is also negative. So is the speed of the particle increasing? Yes. Okay, the speed of the particle is increasing at t equals 3 because v of 3 is less than 0 and a of 3 is less than 0. All right, so that summarizes that part. So for part C, a particle changes direction when velocity changes signs. Okay, so here, for part C, I'm going to look for when is velocity equal to 0. And this occurs when -1 plus e to the 1 minus t is equal to 0. Which if you add 1 to both sides, that gives you e to the 1 minus t equals 1. And let me make that neater. So e to the 1 minus t equals 1. I could just natural log both sides. Natural log of 1 is 0. Natural log and e cancel, giving us 1 minus t equals 0. So at t equals 1. Okay, and one thing about velocity here, or this function, this is the same thing as, let me think of it another way I could say it. I could say that this is, all right, you ready? E to the first times e to the -t, and then -1. So when I think about what this looks like, I'm thinking like it's e to the -t would just drop down like this. So it would hit at, see, it would hit at like 0, 1. But then for this, if I go -1 here, it's going to drag this thing down. So I'm just kind of seeing that it's coming from above. It's going positive and then negative. So that's like preemptively how I know like we're going to go positive, negative here. Okay, velocity is going to be positive and then switch to negative. But if I really want to show, you know, the work in better detail, and oh, greater than or equal to 0. So let me start this at 0. And let's say I put a 1 here. If I look at 1/2, if I were to plug in 1/2, so let's say v of a half, and let's make that, you know, a little bit neater so people could actually see it. So let me write over here. V of a half will give me -1 plus e to the 1 minus a half is a half, which this I know is going to be greater than 0 because if we think about it, once again, I could just think of the graph, but square root of e is greater than 1 because if it's 2.718, the square root of 2.718 is greater than 1. So this is going to be something positive. Okay, and then if I had like, let's say v of 2 would give me -1 plus e to the 1 minus 2 is -1. And this would give me something negative. Okay, so I'd go from positive to negative, and this tells us that the particle changes direction at t equals 1 because velocity changes signs at t equals 1. Okay, so yeah, velocity changes signs at t equals 1. I'll say like positive to negative. Therefore, the particle changes direction at t equals 1. All right, this one I should have put on 2 pages. Changes direction at t equals 1. Okay? Cool. That's 2 points. Now the last part is worth quite a bit. All right, the last part is worth 3 points. So let me shrink this down. I should have gave myself more space, but I don't know, I guess there's always next year. All right, so get this. Group it together. Oh, I appreciate that at Crucial Crazy. I'm just happy to hear like from people now, and also like after the test, people are like, hey, thanks for reviewing. It actually like it made a difference. Like knowing that 2,000 people have stopped by, or 1996, what a year, the year of the great blizzard of 96. But that many people stopped by like means a lot to me. I'm just happy to be able to reach that many people. It's like a really cool day to be on YouTube. So believe me, it's a two-way street. I appreciate you all a lot. So thanks for being here and studying math with me. All right, so part D, total distance is integral absolute value velocity. Okay, from 0 to 3. Except the catch here, see how, actually I shouldn't have got rid of this completely, which I guess it's good it's still here. See how I said a moment ago that velocity is positive from 0 to 1 and then negative? So conceptually, like what's going on, or what I'm seeing, is like whatever this looks like, velocity is like, is here, and then it goes under at 1. And we want to know what's going on from 1 to 3. So if I take the absolute value of velocity, what's going to happen here is the negative stuff is going to flip up. But to handle this, like how do I do that without a calculator? Because this question has no calculator. I go 0 to 1 first, velocity. So this function, I leave it alone. Okay, but then for the negative stuff, from 1 to infinity, but in this case, I'm just going from 1 to 3. How do I get this to reflect up? I just change the sign of everything. I basically multiply this by -1, and I get 1 minus e to the 1 minus t. Okay, let me just make that last part a little neater, like this. Okay, so this is what I'm finding by hand. All right, this is what we have to evaluate. All right, so let's go ahead and do that. For this one, the antiderivative of -1 is -t. And then we have plus the antiderivative of e to a constant x dx is 1 over k e to the kx plus c. Okay, even if it's linear like this, I just say, all right, the coefficient of t is -1. So 1 over -1 gives me -1 times e to the 1 minus t like this. All right, so that's how this one is, going to pop out when we find the antiderivative. And then plus antiderivative of 1 is t. And then when I do the antiderivative here, I get e to the 1 minus t, but then divided by -1, which changes this to a plus. E to the 1 minus t. Okay, from 1 to 3. Now I just plug in carefully and subtract. So I get -1, and I'll say minus e to the 1 minus 1. So that's this part. And then minus, I plug in 0. I get 0 minus e to the 1 minus 0 is 1. And then plus, here I plug in 3. So I've got 3 plus e to the 1 minus 3 is -2. Minus, I plug in 1. And I've got 1 plus e to the 0. Okay, so that's for this part. And this gives me -1 minus e to the 0 is 1. And then minus e to the first, which becomes plus e. And then we have plus 3 plus e to the -2nd. But then I have in here, I have 1 plus 1, but I'm subtracting it, so I get -2. So let's see how this one works out. We're going to have, let's see, this makes -2. So I have e plus e to the -2, but then I have -2 plus 3 minus 2. So that's going to give us, we're going to have 1 minus 2 is -1. Okay, so I have e plus e to the -2 minus 1, and as ridiculous as this looks, It is our answer. All right, so this works out. Why did I make it negative for the second part? Because for finding total distance, you're doing the absolute value of velocity. So you see how over here we said that velocity was negative from 1 to infinity. So I have to break this up, and the negative stuff, I have to reflect it over. And the way you do that is you just negate the function, okay? If you go like f of x to like negative f of x, this reflects over the x-axis. Okay, so transformation of functions. Yeah, just know the AP test, like AP calculus in general, I remember hearing someone say this years ago, it's like 70% algebra, all right? Like your algebra game has to be like super strong. If you don't know the graph, I mean, that's why part C was there, for you to analyze the sign of velocity. Looking for the sign change, it's like you should be thinking about velocity being positive or negative. All right, this is technically AB. All right, but it's still good for BC people. Like, you know, half the test is like on the AB test, so you should know all this. All right, AB5, classic question. Find G of 3, G prime, G double. So once again, this is the formula to know from before. I wrote it down. But this one. All right, whoops, let me just fix that. F of t equals f of x. All right, fundamental theorem of calculus is very big. So for A, G of 3, so let me just get this set up. G of 3, I just plug into my area function here. So see how I have G of x equals integral 2 to x f of t dt. So I'm just going to be using this. So integral 2 to 3 of f of t dt. And we have a graph of f. So the integral from 2 to 3 is the area under the curve from x equals 2 to x equals 3. All right, so that is what we're finding here. And let's just, go ahead and do that. So this one here, we will work out. This makes a trapezoid. So most trapezoids you've dealt with before calculus look like this, like base 1, base 2, and the height is over here. And the area of the trapezoid equals 1/2 height, base 1 plus base 2. But what makes them a little trickier in calculus is the parallel sides are here, going in the vertical direction. So for this, I could say 1/2. The height is the distance between the parallel lines, which is 1, times the sum of the bases. I have 4 plus 2, which gives us 1/2 of 6 is 3. All right, so G of 3 is equal to 3. All right, not too bad. To start, if that bothers you, you could always chop this into a triangle and a rectangle and just add those areas together. All right, but now G prime of x is this theorem, equals f of x. And this is going to be really big for later. Not only is this a graph of f, this is also a graph of G prime. Okay, so G prime of 3 is just the y value at 3. And this is the 0.32, so G prime of 3 equals 2. And now for the last one, G double prime. Well, G double prime is equal to, we just derived this equation to get f prime. So G double prime of 3 is equal to f prime of 3. And that, if I erase this, would be the slope of the function here at x equals 3. And you see how if I'm on a straight line segment here, they said the graph of f can consist of 4 line segments. And this is one of them. So the slope here, we're on the linear segment. We just find the slope of this line and just think rise over run. Okay, then I'm going down 2. So that's -2, and I run 1. So it's equal to -2. All right, so that's part A, 3 points. 1 point for G of 3, 1 point for G prime, and 1 point for G double. Light work. Yes, if you know your stuff, it's light work. If you don't know your stuff, then it's like, uh-oh. So you just got to put the time in. No, it's just 1 point for finding it right. Okay, but yeah, so for this, you just got to like be able to find it. All right, excellent. So part B, find the average rate of change of G on the interval 0, 3. So here, just know the formula. G of 3 minus G of 0 over 3 minus 0. All right, equals, we just found g of 3 is equal to 3. Okay, so we could say 3 minus, and now for this part, g of 0, I'll write this over here. Okay, g of 0, I'm using this function, and I can't just be like, ooh, let me write 0 on bottom and hope no one notices. I have to write from 2 to 0, f of t dt. Okay, and we're dividing by 3. And then I could say 3 plus the integral from 0 to 2. Okay, when you reverse the limits of integration, it changes the sign in front. So now I'll clear this out, and we'll see from 0 to 2. So see the space over here. From 0 to 2, we're finding this area. And see how this is like going over 2, and it's going up 4. So we just have to find the area of that green triangle for, you know, the rest of this question. Okay, so I could say now over here that this equals 3 plus, and I'm doing the area of the triangle is 1/2 2 times 4, and then over 3. Half of 2 cancels, and this gives us 7/3. Okay, so the average rate of change is 7/3. So that's it. All getting 5s. I hope you all get 5s. All right, it's hopefully in everybody's future that a 5 is coming. But if you don't, it's okay. You'll still be you. You might be a little sad, but it's all right. All right, let's see. So just want to double check something real quick. But, oh yeah, friendly reminder to people just coming in. If you've been here and this has been helping, if you could consider subscribing. All right, that's one way it really helps me out with the channel. If we get, you know, plenty of people to subscribe. All right, so anyone who's willing to join, I would appreciate having you on board with us. All right, so hang on, free response is your only hope. Yeah, I mean, I guess, you know, do your best with that multiple choice. I would say if you could do the free response though, and you really, you know, think carefully about the MCQs, that, what's it called? Yeah, like you could figure out, like the MCQs, I know is like a little bit unique, but all right. Oh, and I am drinking Izzy yet again, sparkling mango. That happens to be my favorite flavor. All right. So the average rate of change was 7/3, which is like, I gotta do math. 2 1/3, which is like 2.3 repeating. Okay, so here, part C, remember that number, 2.3 repeating. That they're asking, like, for how many values C, and let me fix this. All right, there we go. For how many values C between 0 and 3 is G prime equal to the average rate of change found in part B? Okay, so I'll say, yeah, G prime of C equals 7/3, which remember we said was 2.3 repeating, which would be like right around here. Okay, remember we said like G prime equals F? So the graph of F is also, once again, the graph of G prime. So when is G prime equal to 7/3? Well, twice, okay? So we would say here there are, they're only asking for how many values of C. There are 2 values of C where G prime of C equals 7/3. Explain your reasoning, because the graph of G prime intersects y equals 7/3 at 2 locations. And this is on the interval, you know, on 0, 3. Okay, that this is happening. So that's it. That's really what we're looking for. So yeah, some people might be like, oh no, MVT doesn't apply because sharp turns, but no, this is a graph of, MVT would not apply to F necessarily because of all the sharp turns, but G prime, we could say, you know, G prime is continuous on 0, 3, which means if G prime is continuous on 0, 3, then G itself is differentiable on 0, 3. So yeah, something to be mindful of here. All right, cool. Now part D, find the x-coordinate of each point of inflection of the graph of G on the interval 0, 7. And, oh yeah, I should point out that you see how this happens also from 0 to 3? Like that this is occurring like twice here. If they had pushed that out a little bit more, then it would just be 1, and that would be like kind of cruel. But, all right, part D, point of inflection. All right, so this is where my head goes. So when they say like G has a point of inflection, I'm thinking like G double prime changes signs. But then I would say the derivative of G prime changes signs. Okay, but the derivative of G prime is also the slope of G prime changes. And when the slope changes, that means the graph goes from either increasing to decreasing or from decreasing to increasing. So notice that happens over here. At x equals 2, the slope of G prime changes from a positive slope to a negative slope. And then over here, we have a slope change from negative to positive. Okay, so we could say find the x-coordinate of each point of inflection and justify your answer. I'll say G has points of inflection, okay, at x equals 2 and x equals 5, because we could say here a G double prime, or I could even say because the slope of G prime changes signs at those values of x. Okay, so that would be our explanation, all right, or justification. Cool. All right, so now, question 6. So we are making progress. This is the last AB question, and then I will be moving on to the BC only. We are at 9 o'clock. So I'm going to try to knock out the rest of them in an hour so people could go to sleep at a reasonable time. All right, so find f double prime of 3. So here's f prime. I would say here, know the product rule. No shame in writing it out like this. Okay, so here it's like u is equal to x. Make that neater. Not my best handwriting. Let's say u equals x. V equals, this one's bad. Square root of f of x. That's the same thing as saying f of x to the half. So u prime is 1, but v prime is 1/2 f of x to the negative half times f prime of x. All right, make sure you know the chain rule. Like if you don't know the chain rule, like, the AP test is going to be kind of awful. So yeah, make sure you know it. All right, so f double prime of x equals, and I'm doing 1 times f of x to the half. Okay, so I have 1 times f of x, but this is to the half power, plus, and now I have x times a half, or 1/2 times x, and then I have f of x to the negative half times f prime of x. Okay, so I'll clean this up a bit. F double prime of x. This is square root of f of x, so I'm going to write it in radical form now. Plus, I have x times f prime in the numerator. See, x and f prime stay up, and then my 1/2, the 2 goes in the denominator, and then f of x to the negative half goes down as square root f of x. And now we got to find f double prime of 3. So f double prime of 3 equals square root of f of 3 plus 3 times f prime of 3 over 2 times square root of f of 3. And f of 3 they told us was 25. So this is square root of 25 plus 3 times, and now side quest, f prime is equal to this. So f prime of 3 is equal to 3 times square root of f of 3, which is 3 square root 25, and then 3 times 5 is 15. Okay, so this is 3 times 15 over 2 times square root of f of 3. And now we just keep simplifying. f of 3 is 25. The square root of 25 is 5. So I'm sorry, that's over here. I should have made that substitution here also. F of 3, I'll just say, is equal to 25. So I have 5 plus, and then I've got 3 times 15 over 2 times 5 is 10. And then for this, I could just reduce. Divide by 5, I get 3 and 2. And this is 5 plus 9 over 2, which is the same thing. I could leave it like this unsimplified, or I could say 10 over 2 plus 9 over 2 is 19 over 2. And there it is. Okay? So 19 over 2. Nice little, wacky scenario there. And now the last part is worth 6 points. This, all right, for tomorrow, make sure, Unit 7, you know how to solve a differential equation by separation of variables. Okay, if you know how to do separation of variables, that puts you in a really strong position to do well. Okay, solve a differential equation by separation of variables. Okay, so that's what I'm thinking here. So part B, dy dx equals x square root y. We have f of 3 equals 25 as our initial condition, and we're solving for y equals f of x. If you don't separate variables, you get 0 out of 6. So please know the algebra. All right, so here, maybe you just cross multiply first and you say dy equals x radical y dx, and then you divide by square root y. Okay, this gets you 1 point. Just knowing the algebra gets you 1 point. And then you have to be able to integrate. All right, please don't say ln square root y, like that's really bad. All right, a lot of people do say it. They see a fraction and they're like, ooh, natural log. This one is power rule. All right, so you're going to say y to the negative half dy equals integral x dx. All right, and you're going to take it from here. So let's go ahead and do that. Let me add another page here so that we have plenty of space. Okay. All right, so now let's zoom in and solve this. So here, power rule, y to the negative half plus 1 is positive half. And then we divide by a half. But when you divide by a half, you just multiply by the flip or the reciprocal. So we get 2y to the half equals 1/2 x squared plus c. And you only have to write plus c once, and I like to write it on the right side with the x because we're always solving these for y. So I like to position the constant next to the x. And now here, f of 3 equals 25 tells us 3 comma 25 is our initial condition. Okay, so this is our x and our y that we're going to be plugging in. Okay, so once again, this is our x and our y. So now this, I'm just going to point out, is not our answer. This is our general solution. We need the particular solution, so we plug in. So we have 2 times 25 to the half equals 1/2 times 3 squared plus c. The 25 to the half is the same thing as square root of 25, which is 5. So we get 10 equals half of 9. So half of 9, I could just say, is 4.5, and then plus c. So c is equal to 5.5. You could also call it 11 over 2, whichever makes you happier. Okay, maybe I'll go with this one. And now I'll plug in. So I have 2y to the half equals 1/2 x squared, and then plus 11 over 2. And now to solve for y, I'm going to multiply both sides by a half. Okay, so we start solving. And I want to point out, when you get to this step, this last bit of algebra is only 1 point. So sometimes that algebra takes forever, but it's only 1 point. So if you get here, like 5 out of 6 is really nice. Okay, so we distribute, we get y to the half equals, distribute here, you get 1/4 x squared plus 11 over 4. All right, and then here to solve for y, we just square both sides. So y equals 1/4 x squared plus 11 over 4 in parentheses squared. Okay, and this is our, this is our equation here. We could leave it like this, and it's fine. So BC people, that is the end of the BC stuff. All right, so moving on now to, I'm going to do a parametric, polar, and then a unit 10 final boss, and that'll be it. All right, so this one here will be calculator. For these questions, it depends on the situation, but sometimes I'll be writing these both in like the function mode and parametric mode. All right, so I'm just going to do that right away here. All right, let me get this all set up. So back to the calculator finally. And I'm going to write this once again in function mode and then in parametric mode. So y1, I'm going to put dx dt. I have 14 cosine of the variable squared. And I have sine of e to the t power. The reason why in this case, I think for the first part of the question, I think this is easier, is they're asking us like, when is the tangent line to the path of the particle vertical? And some background stuff, what we have to know here is that in polar, if I have like this is not necessarily this curve, but if I have some curve that looks, I don't know, let's say something like this, it could just be all over the place. The slope here, the slope dy dx is equal to dy dt over dx dt. Okay, I could also say like, or dy dx. Sometimes we'll write, y prime t over x prime t. Okay, but that's like one of the big ideas. So when is the line tangent vertical would be when x prime of t equals 0 and y prime of t is non-zero. Okay, I want to show that this is happening here. All right, so now I'll go ahead and switch back to what I was doing in the calculator. But I wanted to give some background, like why are you doing this, whatever it is you're doing. All right, so dy dt is 1 plus 2 sine of variable squared. And for this one, first I want to know when is the blue equal to 0. Okay, so I'm also going to point out that the domain is from 0 to 1.5. So I'm going to switch my x max to 1.5, and now I press graph. So you see how we have two roots here? That's the denominator is equal to 0 at these two locations. Okay, so now I'll go ahead and graph y equals 0. So I could just do second trace intersection and see the intersection here for both of these. So we have this time, okay? So this is occurring here at first we have, let's just see. This happens at, let me make sure I just didn't make a typo. Something might be 14 cosine of t squared times sine of e to the x, and then this is 1 plus 2 sine of x squared. Okay, because before, I want to say I wrote this in and I got something. Let's see, let me try that again. Let me see, on the graph, second trace 5. Oh, you know what happened? It might have flipped to, oh, that's why. All right, that's what happened. Second trace 5. So look, a workaround is I could turn this graph off. Remember when I talked about before pressing enter here? So second trace 5. And now I'll just stay with these. All right, that makes it better. Okay, so this would be one time, and then second trace 5 is this one. All right, and I want to point out, once again, if I turn the other graph back on, see how dy dt does not equal 0 at all from 0 to 1.5. All right, it's strictly positive there. All right, so I could mention that when I, write up the solution, which, I will. So at what times is the line tangent vertical? It's going to be at 1.145 and at 1.253. Okay, so the tangent line is vertical at t equals 1.145, I'll round it to, and t equals 1.253, because, so we need some justification here, I'll say dx dt equals 0 and dy dt is non-zero at those times. Okay, so I'm just providing like how I know. Setting the denominator equal to 0 is definitely, the way here, that x prime is 0 and y prime is non-zero. All right. The 0 over 0 is like one of those indeterminate forms. So you know how like when you're finding limits, like when you have 0 over 0, a lot could happen. Like let's say I have like the limit as x approaches 0 of like, let's say x squared over x squared. So like this, you might be thinking like, oh, all right, that equals 0 over 0. But in this case, the limit actually simplifies to 1. So it's like sort of like something to do with unit 1. But yeah, that's the idea. Like division by 0, sometimes it means vertical asymptote. Sometimes it means removable discontinuity. Okay. So here, if the numerator is non-zero and the denominator is shrinking to 0, it makes the asymptote. All right, but good question. That's like one of those sneaky details that, sometimes gets overlooked. All right, so that's A. And now part B is a fun one. Write the equation for the line tangent to the path of the particle at t equals 1. All right, they told us at t equals 0 that this is the position. So this tells us x of 0 is -2 and y of 0 is equal to 3. So here we're going to use the fundamental theorem of calculus. We need to know, once again, what's happening at t equals 1. So the position at 1 is equal to the position at 0 for the x plus the integral from 0 to 1 of x prime of t dt. Okay? I'll even say over here, I'll say like, x prime of t equals dx dt, y prime of t equals dy dt. All right, but this is like one of those things. I'd be shocked if they like zapped a point for you not communicating that. But if you're going for that 108, that perfect score, then like, hey, like make sure you say all that stuff. All right, so now you got x of 1 equals x of 0 is -2 plus integral 0 to 1 x prime of t dt. And this I'll just go right to the calculator. All right, and I might as well set up the other one as well. So for the other one, I'll do this for y1 is going to be equal to y of 0, or 3, plus integral 0 to 1, and then y prime of t. Okay, so I could get both of these right on the calculator. And that's what I'll do now. So back to the main screen. And for this, I could type this in parametric mode, if need be. If you'd rather see this part in parametric, you know what, I'll go ahead and show that just because it is BC. So you switch the calculator to parametric. And here I have 14 cosine of t squared. And then sine, whoops, wrong button, of e to the t power. And then y is 1 plus 2 sine of t squared. Okay, and then if I'm on the main screen here, I could just write this in now. X of 0 was -2, so I have -2 plus math 9, 0 to 1. And then x prime, if I press alpha trace, was saved in the x1 spot. And that gives me 9.314. All right, and then for this one, y1, y at t equals 1 is 3 plus math 9, 0 to 1. And then dy dt was saved in the y1 equation. And that gives us this. For the slope of our tangent line, I could just go, well, the problem is, all right, here's a trap. If I press second trace this and then t equals 1, the reason why this is no good is because this is already the derivative. These are not the position functions. Okay, so if you put your position equations in, then yes, you could find the derivative doing that. But that's why for this, we have to know the idea that I wrote up here. Oh, did it get covered? Yeah, that dy dx is equal to y prime over x prime. And this is already y prime x prime. So when I need to find that slope, I could just do that here. I could write alpha y equals enter, make a fraction, and sorry, let me scroll. And we're finding this all at t equals 1. So I could do alpha trace. This is dy dt, where y prime at 1 over x prime is in the x1 spot at 1. Okay, because I already typed in the derivatives. So sneaky detail, like if you forget that, it would be like kind of devastating. All right, so calculator saves the day. So, I mean, yeah, like the math itself is like not the worst here because the calculator is doing a lot of the heavy lifting. But you have to know like what to tell the calculator to find. All right, so now I'll just record these results. So x of 1, we could say was equal to 9.315 if I round. And then this one was 4.621. All right, just making sure I got the right values. And now I have to communicate how I'm finding the slope. So I could say y prime of 1 over x prime of 1 was 0.863. So now the tangent line I'm going to write in terms of t. I'm going to say y minus the y value equals the slope times t minus the x value, 9.315. All right, and that would be it for part B. All right, so that one was a lot. Part C is like a bit of a break because now it just gets easier. And so is like part D. Just know part D is like not always the worst. Sometimes, yeah. Why do we need the values at 0? Good question. Because remember from even Calc AB, the integral of velocity is displacement. But you need to know like how far did you move from your starting position? You know, like if I just say, oh, I took 5 steps forward. It's like, well, where are you standing? Are you standing in like New York? Are you in Kansas? Are you in California? Because taking 5 steps to the right will place you somewhere radically different depending on where you're starting from. So your starting location needs to be accounted for. All right. Or what you could think of, like why we have to include x of 0 is fundamental theorem of calculus. The integral of x prime from 0 to 1 by the fundamental theorem of calculus is x of 1 minus x of 0. So when I want x of 1, I just add x of 0 to both sides. So it's FTC. All right, now part C, just know the formula. Part C has the potential to be very easy if you know speed. Okay, so speed at t equals 1. So that's x prime of 1 squared plus y prime of 1 squared. Okay, that is how you find speed. So then I just go to the calculator. And like I hope I don't make a typo. All right, so remember, x prime and y prime are saved in x1, y1. So I just go square root, and I go alpha trace. So there's x prime at 1. I close the parentheses and square, plus alpha trace y1 at 1. Close the parentheses and square it. And it's 4.105. Okay, so 4 point. Not bad. Okay. And then acceleration at t equals 1 is the derivative of velocity at t equals 1. Okay, so here I would just say, you know, the acceleration vector. So let me zoom out a little. So let's just say like, yeah, that the acceleration vector, that's just going to be, we'll say x double prime of 1, comma y double prime of 1. So this is equal to, and I just use the calculator for this. All right, if you want to point out, like, just say here, like, you know, acceleration is equal to the derivative of velocity. Like, that's where this is coming from. Okay, so that's why, you know, we're using this idea over here. So for this, I just go right to the calculator and press math 8. So let's do that. So math 8. The derivative of our x velocity at t equals 1. And then next, we've got the derivative of our y velocity. So I'm going to press alpha trace y1 is where the y velocity is saved. And then these are the values we need. But for this, like communication notation, make sure that you write this as an ordered pair because they're asking for the acceleration as a vector. So if you just write the numbers separately, they could zap a point for that. Okay, so here I would just say negative 28.425 and then 2.161. All right, that's it. That's all there is to it. So that is parametric. Okay, cool. All right. Oh, wow, 306 people here. How awesome. I'm so happy once again that you're all a part of this. Thank you. Thank you, thank you, thank you. We had 3,777 people stop by. That is pretty awesome for the live. That is, yeah. I still like, yeah, have trouble sometimes believing it. Like, it's just so cool. I know we're past the peak. Like now this is like the late hours, but yeah, I am going to try to get through this by, let's see what. Okay. Yeah. I'm going to try to finish this before 10. All right. So this one coming up is going to be no calculator. All right. So is this the no calculator one? I believe, let me just check. Cause this is like an old test. They like had different rules back then. It was like kind of all over the place. Yeah. This one's no calculator. All right. So that's good. Cause these could show up in the no calculator section, like, you know, questions in the multiple, like this could show up in the multiple choice, sort of like these kinds of like no calculator stuff. But this is the Lima-san with the inner loop. So like if I drew the full thing, it's like, oh, whoops, that was terrible. Here, you know, I'll just kind of like use this one as a reference. It's like this one, see, but it's like half of the Lima-san inner loop. And we want to find the area of S. So one skill you need is you have to know how to like kind of track theta and r. So like if I start at 0, see how I get r equals 1 minus 2 cosine 0? And that's going to give us 1 minus 2 is negative 1. So this tells me when I'm facing theta equals 0 to go negative 1. So this is like kind of like where I'm starting here. And then if I plug in, and I could just plug in, or if you know trig equations, you could just solve this. When is r equal to 0? So when is 1 minus 2 cosine theta equal to 0? This is going to occur when 1 equals 2 cosine theta. And this means 1/2 equals cosine theta, or theta equals pi over 3. Okay, so that's when we hit 0, at pi over 3. All right, there is another time, like if you think of this one here, the ASTC, all students take crack. No, joking. All students take calculus. That's the better one. But cosine is also positive in quadrant 4, but we're stopping at pi. So we're only looking at like, you know, these quadrants. So that's why pi over 3 is like enough. And this tells us like we start here and we stop at theta equals pi over 3. Now this usually throws people off because they're like, wait, this should be theta equals 0. But remember, theta equals 0 is here. One of the first topics in unit 9 for polar is like learning how to plot polar points. So that is the key to being able to find polar area, is that you're sort of like able to track what's happening. Like what I imagine is like, here's my radius. And like, as we rotate through, see how like the radius is like starting to shrink. And I think of like a windshield wiper in a car, like how it does this motion, and it's going to swipe the area S that we need. So A, we're using the formula 1/2 theta 1 theta 2 r squared. And for this one, yeah, we just set this up. They just want us to write an integral expression, but not actually find the area. Okay, so it's 1/2 integral 0 to pi over 3. And let me make this like, you know, a little bit more jumbo font. So 1/2 integral 0 to pi over 3. And then just r squared. So 1 minus 2 cosine theta and then squared t theta. Okay, so that's part A. Part B is nice. For that, the key is knowing basic polar stuff like x equals r cosine theta and y equals r sine theta. So for this, like when I have to find dx d theta, I'm just deriving this with respect to theta. So I'm doing the derivative with respect to theta of this. And this gives us dx d theta equals product rule. So I'm doing the derivative of r is dr d theta times cosine, but then plus r times the derivative of cosine is minus sine theta. And we are deriving with respect, or taking the derivative with respect to theta. So that brings us here. But now, in terms of theta, so I have to plug in for r and dr d theta. If r equals 1 minus 2 cosine theta, then dr d theta is equal to 0 minus 2 times the derivative of cosine is negative sine. So this makes 2 sine theta. So now I could plug in and then simplify this a little bit. So I could say dx d theta equals dr d theta is 2 sine theta. And then we have cosine theta minus r is, and I'm going to write sine first. So minus sine theta times r is 1 minus 2 cosine theta. And for this, it's no calculator, so I don't have to simplify, but you know, I just will for this one. This is 2 sine theta cosine theta, and then minus sine theta, but then plus, because I'm doing minus times minus, plus 2 sine theta cosine theta. Okay, so dx d theta equals 2 sine theta cosine theta plus 2 sine cosine is 4 sine theta cosine theta, and then minus sine theta. Okay, so this is like a little bit of a mess, but this is our equation. All right, so that's dx d theta. dy d theta is something similar. So let me just add another page here because this is becoming like overpowering. All right. They'll give you plenty of space to write, not to worry. Okay. So here, dy d theta. Now I'm starting with that equation, the y equals r sine theta. And I'm taking the derivative with respect to theta. And this tells us dy d theta equals the derivative of r is dr d theta times sine theta, and then plus r times the derivative of sine is cosine. So product rule shows up here, but now in terms of theta, so I have to substitute it in again. So dy d theta equals dr d theta is 2 sine theta. But when I multiply 2 sine theta by sine theta, that's 2 sine squared theta. And then plus r times cosine. So I have cosine times r is 1 minus 2 cosine. And you know what? This one, I'll just leave it like this. Okay, so we have part B is done. And now part C, write an equation in terms of x and y for the line tangent to the graph of the polar curve at the point where theta equals pi over 2. Ooh, all right, so this one, for part C, so I'm going to say what we need to know. dy dx is equal to dy d theta over dx d theta. Okay, so for this, dy dx equals 2 sine squared theta plus cosine theta times 1 minus 2 cosine over, and then we have 4 sine theta cosine theta minus sine theta. So this one at pi over 2, I'm going to plug in. So dy dx at theta equals pi over 2 is equal to, this is going to give us 2 times sine theta is 1. So when I square it, it's just going to give us the 1 here. But then plus cosine of pi over 2 is 0. So 0 times this just wipes out. And on bottom, I have 4 times sine pi over 2 is 1 times 0. But then minus sine pi over 2 is 1. So this makes 2 over negative 1, which is negative 2. So that's the slope of our tangent line. But now, from before, let's see. We also need to know what our x and y is. So x is r cosine theta, and y is r sine theta. So let me write that down. And one thing I'll point out from before, r equals 1 minus 2 cosine. So r at pi over 2 is equal to 1 minus 2 cosine pi over 2, which is just 1. Okay, so now when we say x equals r cosine and y equals r sine, I could say that x at pi over 2 is equal to, tell me I could just use the graph too, and I'm just doing all this for nothing. Let's see, pi over 3. It's probably just going to be here at 0, 1. And that's just devastating, but whatever. This is good practice, so we'll do this. Now I'm committed. All right, so r is equal to 1 times cosine, yeah, of course we could, is equal to 0. And then y equals 1 times sine pi over 2 is 1. So the point is 0, 1. So this is like our, our x1, y1, and our slope is here. Okay, so the tangent line, this I could just use y equals mx plus b, because this is a y-intercept. So y equals negative 2x plus 1. Okay, that's our equation. Awesome. Now we go on to the final boss. Last question. What's my prediction for BC FRQs? Rate in, rate out. I want to say this year is going to be polar, like they're going back. It's been like 5 parametrics in a row, but I mean, whatever. I guess it'd be fun if they did parametric again, but I'm just going to say polar just because. And then graph of f prime, differential equation with Euler's method and integration by parts. Then 5, I think, will be something like, let me think. Maybe, I already said differential equation. So 5, maybe like a volume type question, unbounded region, volume. Actually, no, I'm lying, because if differential equations is the BC topic, then they're only going to do 3 BC onlys. So, all right, let me say rate in, rate out, polar, graph of the derivative, like graph of f prime type situation, or graph of g prime. Then it's going to be differential equation with Euler's method and integration by parts. 5 will be, or maybe 5 will be the diff EQ, but either way, 5 will be like unit 8, maybe like volume of revolution, area between curves, that kind of stuff. But if it's polar and you're finding area, they're not going to double down on that. So Riemann sum. All right, how about that? Like Riemann's, something like Riemann summish with MVT. Okay, so that, and then 6, of course, unit 10. All right, I'm gonna guess. Yeah, that's my guess. What belt am I? I got to 1st degree black belt in Brazilian Jiu-Jitsu. Yeah, that's my. I haven't trained since like September. I was like on the fence about going back anytime soon because of injuries. I trained jiu-jitsu like since 2010, and it's really like rough, like of a sport, but it's a lot of fun, and I do like it, and I do miss it. But eventually I'll go back. It's tough. That one hit a nerve. That's good though. I'm glad you asked, but it's been definitely hard sitting out because there's like only so much time to do all this stuff, and I've been putting more time into like writing my next YouTube videos, and my main time though is like being a family man. Am I ripped? I mean, for 37, I'm like okay. I think I'm like in decent shape. I'm not like mega jacked, but I'm like okay. I could still do like over 10 chin-ups, I would say. So, and I eat a lot of chips and stuff. So if I lost like 20 pounds, I could probably do 20 chin-ups. Could I get 100? All right. If I got like a really like good full night's sleep, I would break 100. I don't know if I would get a 108, but I think I would be like close enough if I'm sharp that day. Like if I took 10 AP exams, then it's like maybe like a few of them would be perfect. But it's more about like like higher math is not about like, ooh, I'm perfect all the time. Like the questions later are slower and you have like really long to do them. Like higher math is not like, all right, who can answer, what is it? Like 54 questions in 3 hours. It's more like one question that you spend a month on. So, but it's still like a good class to take for sure. All right, so here we go. Final boss. What you need to know. So for this, f has a Taylor series about x equals 2, converges to f for all x in the interval of convergence. The nth derivative of f at x equals 2 is given by whatever. So formulas, I'll say you need to know f of x equals this one. So the nth derivative at the center. I mean, really just got to know this one. Okay, if it's Maclaurin, c equals 0. So Maclaurin is going to be like this. Okay, then x to the n over n factorial. All right, but for this one, we're centered at 2, so it's Taylor for this one. And Taylor is like center, it could be anywhere. Maclaurin is only centered at 0. So for this, what I'm thinking is like, all right, f of x equals f of 2. So not only do you have to know the packaged version, the expanded one is very helpful. So it's like f of 2 plus f prime 2 x minus 2 to the first over 1 factorial, but then plus f double prime 2 x minus 2 squared over 2 factorial. So we need the first 4 terms. First 4 terms in the general term. Okay, so this over 3 factorial, and then plus dot 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 nth derivative at 2 x minus 2 to the n over n factorial. So this is what we need, and I'm going to write plus dot 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 because the Taylor series is infinite. Taylor polynomials are finite. So technically, if I stop here, I'm like being sloppy. So this goes on forever. Okay, so now that we got this, I'm going to get rid of this stuff. All right, if you're like, oh no, he's erasing, then just rewind because this is YouTube. Okay, so we get that last piece out. All right, last question here. Whoops, stuck. No, move. All right, here we go. So now it's like a little bit, oh, the board, like this thing is possessed. I say that in my classroom all the time. I'm like, oh, my board is possessed when this happens. But okay, so f of 2 is equal to 1. This part I take my time because I don't want to mess this up. My nth derivative at 2 is equal to this. So if I want my first derivative at 2, I plug in n equals 1. Okay, I plug in n equals 1, and that gives me like my first derivative at 2. Okay, so I plug in n equals 1, and I have 1 plus 1, first day of school, is 2, factorial, over 3, and I'm plugging in n equals 1 first to get this, which gives us 2 times 1, which is 2 over 3. And then f double prime of 2 would be the result of plugging in n equals 2. See, I would get like f parentheses 2 of 2. That means the second derivative at 2. So when I plug in 2 for n, now I have 2 plus 1 in parentheses, which is 3 factorial over, and then I plugged in n equals 2. I have 3 to the second power, which gives us 3 times 2 times 1 is 6. Okay, remember, 3 factorial doesn't mean shout 3. Okay, you're not going to shout it at me. It means 3 times 2 times 1. So it's 6 over 9, which reduces to 2/3. All right, and then f triple prime 2 would be plugging in n equals 3. See, I would have my third derivative at 2. And 3 plus 1 is 4 factorial over, and let me make space, 4 factorial over, I'm plugging in 3 to the third power. So 4 times 3 times 2 times 1 is 24 over 27, and this makes 8/9. Okay, so these are all the pieces I need to be successful. And let me, you know what, let me move them here so I have, more space for this. Whoops, don't want to drag too much. All right, so this, actually I'll just, because I'm going to have to go to the next line anyway. So whatever, I'll put it here. I feel like this will be less cluttered. All right, so now I'm going to plug into the purple. Okay, so f of x equals f of 2 is 1 plus f prime 2 is 2/3 times x minus 2 plus f double prime 2 is 2/3. We have x minus 2 squared, but we are dividing by 2 factorial, which is 2. And then plus f triple prime 2 is 8/9 x minus 2 to the third over 3 factorial is 3 times 2 times 1 is 6. Okay, plus dot dot dot. The nth derivative at 2, we got to use that whole formula. All right, that's n plus 1 factorial over 3 to the n times x minus 2 to the n over n factorial plus dot dot dot. Now this is where being good at algebra helps, But technically, you don't even have to simplify this. But I would simplify it because doing the ratio test in part B is going to be a nightmare if your general term is not simplified. Okay, so like let's simplify this. So f of x equals 1 plus 2/3 x minus 2. Now, depending on how good 5th grade was for you, depending on how strong your fraction game is, when you do 2/3 divided by 2, this is the same thing as saying 2/3 times a half, which makes 1/3. Okay, so this is plus 1/3, and then x minus 2 squared. All right, so I'm just hoping here that I don't say anything too crazy. Trying to be as accurate as I can here. I'm pretty sure like everything's been clean. I have the rubrics next to me, like just kind of in case I say 5 plus 5 is 12, but this is, looking good. Now, 8/9. Oh, Wrath of Math, thank you so much for the support. I appreciate, the support. And wait, I feel like Wrath of Math. Yeah, you have a shout out to Wrath of Math. Like I feel like I've stopped by your channel before. And your channel is excellent. I believe you were the guy who did like the 10-hour FRQ. So I appreciate your work on the space as well. And one of my peers like stopping by. So awesome stuff. So thank you for supporting. It's cool to, get a shout out from someone like you. And hello at Fortnite Sweaty Kid. I know like we've been together now, like working together for like, I don't know, 3 years or so. So, he did do 10 hours worth of FRQs. So definitely a shout out. Those kind of videos like pop up in my feed and I'm like, oh, wow, what a hero. That's a lot. I mean, should I just pull an all-nighter to the test? No, I'm not going to do that because I have other stuff to do. But yeah. All right. Cool. So next up, we've got plus, and then 8/9 divided by 6 is the same thing as times 1/6. So we don't have to simplify here, but I don't know. I feel like my, 4th grade teacher is shouting from far away if I don't. So this will make 4/27. So I'll get rid of that now because I just want it to look cleaner. X minus 2 to the 3rd, and then plus ... Now this one, n plus 1 factorial. Let me write it over here. N plus 1 factorial over n factorial. This is the same thing as m plus 1 times n minus 1 and so on. Or I could just rewrite it like this. Simplifies nicely to just m plus 1. Okay, so the plus ... I'll just write this over here. Just becomes, when we divide these two, we just get m plus 1 over 3 to the n times x minus 2 to the n plus ... Okay, so here are the first 4 terms and the general term. All right, and I just want to double check with the rubric next to me that everything is looking good. So 1 plus the 2/3 plus, 4/27 and so on. I could even use the formula to check because the formula should check out here, but it does. It's a good question. All right. So now radius of convergence. I'm going to use the ratio test. Okay, you should absolutely know the ratio test for the FRQ because if it does show up, it's worth a decent amount of points. Okay, so the ratio test for part B, we're going to do the limit as n goes to infinity. Think of this part here as like your a sub n. So we're going to do a sub m plus 1 over a sub n. So if I do if I replace the n's with m plus 1, I get m plus 1 plus 1. Okay, so here times x minus 2 to the n plus 1 over 3 to the n plus 1. Like this. Okay, the time to be careful is if it's like a 2n. If you ever have like a 2n, you got to go 2 times n plus 1 and it distributes. But that didn't happen here. But I just want to point that out that I've had that trick people plenty of times in the past. All right, times. And now we've got 3 to the n. Because all right, so for one, I'm doing a sub n plus 1 over a sub n. So that's the same thing as multiplying by the reciprocal. So I get this. And then times this. Okay, so we're here. And now this will simplify. I'm still learning how to use this like new Wacom tablet I got. I upgraded it. And sometimes it just like takes over on its own. So now this cancels and this becomes a 1. This one cancels out completely and this becomes a 1. Okay, so now that we have the limit as n goes to infinity, and now I'm going to keep these two together. The x minus 2 over 3, I'm going to say is, yeah, absolute value x minus 2 over, let me make that neater. I could say over absolute value 3, but the absolute value of 3 is just 3, so that could pop out. And now times, we've got m plus 1, which is m plus 2 over m plus 1. And now this I could leave in absolute value, but n is going to infinity. So these two things are positive, which means they could leave the absolute value. But I mean, either way here, it's going to simplify nice. So here, leading terms, we're going to infinity, matching powers, matching coefficients. So this limit goes to 1. So I just get absolute value x minus 2 over 3. So that is our limit. But now we set this to be less than 1 because the ratio test shows convergence when the limit comes out less than 1. And now I just multiply both sides by 3. And that tells us absolute value x minus 2. So make this neater. Oh, this is starting to freeze up on me a little. So this is less than 3. And this tells us our radius of convergence is equal to 3. Okay, so I'm just going to say the radius of convergence is equal to 3. Now, if you're like, wait, how do you know that? Now, from here, I could go x minus 2 is less than 3, but then put a less than negative 3 here and go plus 2 if I had to. But we're not solving for the interval of convergence. That's why I don't recommend that you show like too much extra. Because if you say extra and you say something silly, then you lose points. Okay, so here, from negative 1 to 5, the center there would be a 2, which should make sense because you see how the general term had an x minus 2? So the center here would be 2. And we also were told in the beginning, like, we're about x equals 2. So that's our center. So the radius, you see how we're going like 3 this way? We're also going 3 this way. Okay, so this is like the interior of the interval of convergence. Okay, if we had to find the full interval, we'd plug in x equals negative 1 and x equals 5 for the general term. But that's not what they're asking, so don't do all this extra work. Okay, so now part C. Let's see, g is the function. Ooh, all right, this is a good one. I'm just going to borrow this because there's a lot to keep scrolling. So let me screenshot this. So cut and then paste just because I don't want to have to scroll back up and down, 500 times. Okay, so part C. Now what we want to do is we have g is the function satisfying this. Oh, this is a nice question. And g prime equals f for all x. Write the first 4 terms in the general term of the Taylor series for g about x equals 2. So we could do that whole process all over again, like find g of 2, g prime 2, and so on. But there's a fun way to do this. So for this, what I want to do is I want to take f of x, and I'm going to first write it over here because I will forget. But I'm going to say here that f of x equals the series from n equals 0 to infinity of, we had n plus 1 times x minus, and let me move this over. So we've got n plus 1 times x minus 2 to the n over 3 to the n. And just a quick test, if I plug in 0, I get 1 times x minus 2 to the 0 is 1, over 3 to the 0 is 1. So this starts at 1. And then at n equals 1, I would have 2 over 3, x minus 2 to the first. So this is definitely capturing what's going on here. So I'm going to borrow this. All right, so I'm going to take this, and I'm going to borrow this over here. So this was f. And what I'm going to do with this, so I'm going off the rubric here, because the rubric showed a different way, but I like this way more. They told us that g prime of x is equal to f. So I could say g prime is equal to this. And if I want to find what is g of x, I could just take the antiderivative of this power series. All right, you're allowed to differentiate, or you're allowed to differentiate and anti-differentiate a power series. Okay, that's one of the skills you need to know. All right, I'm going to put a dx here. But this is an indefinite integral. So when I find the antiderivative, I'm going to say C plus. And now I do the antiderivative, but I target the x term. See, I'm targeting this. So this becomes m plus 1 times x minus 2 to the new power is m plus 1. But now I divide by that new power m plus 1. And now the m plus 1's cancel. And this tells us g of x equals c plus n equals 0. And this is x minus 2 to the m plus 1 over 3 to the n. But now, remember what we just said here. G of 2 equals 3. But g of 2 would equal c plus, if I plugged in 2 for x, 2 minus 2, the center's at 2, so that just wipes out the whole series. And g of 2 is equal to 3. So this tells us the constant is equal to 3. So this is like unit 7 meets unit 10. All right, so then g of x would equal 3 plus this series. All right, I like this way. I think this way was like pretty cool. And it does give you the exact same answer in the rubric. So it's like, it checks out. This is like, you know, a solid method. But they did say to write the first 4 terms. Okay, so this is the first term, 3. So the first 4 terms, I'd have 3 plus, if I plug in 0, I get x minus 2 to the 0 plus 1. Or I just get, x minus 2 to the first over 3 to the 0. But if I write over 3 to the 0, that's just 1. So I don't need that. And then I get plus, I plug in n equals 1, and I got x minus 2 squared over 3 squared plus x minus 2 to the third. See if I plug in, wait, I'm lying here. It was just a joke. I was testing you all. So here, let me start that sentence over. This was plugging in n equals 0, n equals 1. The power here and here should be offset by 1. Okay, they should not match directly. Okay, so then plus, now I plug in n equals 2, and I would have x minus 2 to the 2 plus 1 is 3 over 3 squared. Okay, so these are the first 4 terms, and then plus the general term is the x minus 2 to the n plus 1 over 3 to the n plus dot dot dot. Right, and this goes on and on forever, but this does give you the same stuff in the rubric. All right, but I don't know, I personally like this way more, like seeing that you just take the antiderivative of the power series, because there you had to build it from scratch again, and that's just exhausting. All right, part D, the final piece. Okay, does the Taylor series for G, there's no way I'm remembering all that. Okay, so this, all right. So this one, does the Taylor series for G as defined in part C converge at x equals -2? So let's see. Well, what we can see here, for this, we could investigate. There's 2 ways. We could go G of -2 equals 3 plus this, and say, you know, -2 minus 2 is -4 to the n plus 1 over 3 to the n. And then, you know, sort of like morph this into like a geometric series. Like go like, all right, -4 times -4 to the n over 3 to the n. And then you could call this sigma -4 times -4 thirds to the n. And say that this series diverges. Okay, this diverges. And why does it diverge? Because the common ratio is -4 thirds. And the absolute value of -4 thirds is greater than or equal to 1. Okay, so that's why it diverges. So does the series converge at x equals -2? No. But the easiest way to do this is recognizing that G was the antiderivative of f. And in part B, we found the radius of convergence here. Okay, so I'm going to borrow this. So we already did the work that we need. So copy and paste. So for this one, what we have is, we could say, once again, the series for G G only converges when the absolute value of x minus 2 is less than 3. And you could say x equals -2 implies absolute value of -2 minus 2 less than 3, or this less than 3, which is not true. All right, therefore, the Taylor series for G does not converge at x equals -2. And this is it, people. All right. So I just want to say, yeah, thank you all so much for being a part of the live stream. I'm kind of like blown away here. 5,538 people swinging by, and thank you for the tips. Of course, I appreciate you all. Thank you, thank you, thank you. Yeah, just good luck. Hang in there. And if you're anxious, it's normal. It's normal to be anxious before a test, especially a test as big as this. But try to see tomorrow as just another day of school. All right, you show up, you do your best. And yeah, I'm proud of you, and thank you all for hanging in. If you're like, oh wait, I want to watch more stuff, you could go to my AP Calc ABBC review playlist. I have my live streams from last year where I did, quite a bit last year as well. But thank you and good luck, everybody. So I'm signing out now. Take care.